So for 3, 6, we finally get to multiply two matrices together. So here's the catch with multiplying matrices. When you multiply them, the columns in the first matrix has to be the same number of rows in the second matrix. So if I label these, rows by columns, the middle two numbers have to be the same. Okay, see how that's got to be that way. So let me try and do an example and see if I can explain that. By the way, the new matrix is going to have the dimensions of the, quote, outside numbers there and there. So determine whether each matrix product is defined. State the dimensions of the product. So I have apparently a 3 by 4, that's what matrix A is, being multiplied by a 4 by 2. So are the middle two numbers the same? Does the first one have the same number of columns as the second one has rows? The answer is yes. So my new matrix is going to end up being a 3 by 2. Okay, and we can call that answer maybe matrix C or something. So 3 by 2, though, is your answer. If your matrix doesn't have the same, these middle numbers being the same, it's not possible. Okay, so this one is not defined because those middle numbers aren't the same. 1B is going to end up being a 4 by 2. I'm sorry, 1A is a 4 by 2. 1B is going to be not defined. Okay. So let's actually do that. Basically what's going to happen is you're going to be overlapping the row onto the column. So here I have A and B. That's going to get overlapped onto E and G. So the A and the E will go together. The B and the G will go together. See how that's commented on over here? A times the E plus the B times the G. And you basically just do that until you run out of rows and columns to put together. So let's go ahead and just do an example here. By the way, the first thing I'm going to do is quick figure out. This is a 2 by 2. This is a 2 by 2. So my final answer, if you can kind of think of it like maybe the middle numbers, quote, cancel. They don't really cancel, but that's how you can think of it if you want. So that my outside matrix is a 2 by 2. Or my resulting matrix is a 2 by 2. So I take the first row times the first column. You might write that somewhere. Row times column. Remember that. So 5 times 2 is 10. Then you'll be adding 9 times 6. I'm going to go ahead and maybe write all of it out here the first time. Because it was the first row, first column, this gets to go in the first row, first column location. So now let's do this row. Maybe I'll change colors here. So now I do row times column. So the first two elements together, 5 times -1 plus 9 times the -5. Now that I've done all the columns with my first row, let's do the second row. If I do second row, first column, then my answer will go in the second row, first column location, and it will be -3 times 6 plus the -2 times 6. Hang on, I messed up. That shouldn't be a 6 there, should it? That should be -3 times 2. And then -2 times 6. I apologize. Alright, last but not least, second row, second column means it should go in the second row, second column location, so that's where I get to write the answer. And that's going to be -3 times -1 plus -2 times -5. And basically now just simplify until you have a final answer. So that should be a parentheses there. 5 times 2 is 10. 9 times 6 is 54. And 10 plus 54 is, 64. Okay, then let's do the same thing over here. 5 times negative 1 is negative 5. And 9 times negative 5 is negative 45. So I recognize that that just gets to be negative 5 minus 45. So the answer is negative 50. Negative 6. Negative 12. That's going to be negative 18. And last but not least, 3, 10 is 13. Draw your matrix brackets, and you finally have your answer. All right, so when it came to addition, we didn't care what order you add things in. And with regular boring numbers, we don't care about the multiplication. However, with matrices, multiplication is going to matter. So let's try multiplying G times H. So I'll be doing this row by this column. So 1 times 2 is 2, plus 3 times negative 2 is negative 6, plus negative 5 times 1 is negative 5. First row, first column, so it gets to go there. Now if I'm going to do first row, second column, that's going to be 1 times 3 is 3. 3 times negative 8 is negative 24. Negative 5. Negative 5 times 7 is negative 35. And let's see, we'll go on to second row, first column. That means it needs to go in the second row, first column location. So 8. 4 times 2 is 8. Negative 2 times negative 2 is positive 4. And 0 times anything is 0. Last but not least, second row, second column goes in the second row, second column location. 4 times 3 is 12. Negative 2 times negative 8 is 16. And 0 times anything is 0. So I'm going to go ahead and simplify, write my final answer. 2 minus 6 minus 5 is negative 9. Let's see, 3 minus 24 minus 35. How about negative 56? 8 plus 4 plus 0 is 12. And 12 plus 16 plus 0 is 28. So this is the answer I get when I took G. Oops, that wasn't a very good G. When I took G times H, it gave me that. Check it out. They already did H times G for you. Notice, not the same matrix, okay? So it matters what order you multiply in. Make sure you multiply in the correct order. The distributive property, we're going to kind of maybe skip doing that one for now. But notice that if you distribute first, that's fine. Or if you multiply or add inside and then multiply, that's fine too. You're going to get the same answer. All right, and I think I want to actually maybe try this one. Or at least maybe set it up for you. So on here, first I would be doing this row times this column. That would give me the answer in the first row, first column location. Then I would come through and do first row, second column. That's going to give me an answer in the first row, second column location. Okay, first row, third row, boom. And let's see, second, ooh, I already did that color, didn't I? Let me try again. How about second row, first column gets me second row, first column. Second row, second column gets me second row, second column. And last but not least, second row, third column gets me second row, third column. Okay, and simplifying, that would be your answer. This is an example where we get to see a 2 by 3 be multiplied by a 3 by 3, and my resulting answer is going to be a 2 by 3. So your matrix can change dimensions based on whatever you're multiplying together. This is definitely weird, so let me know if you have any questions.